Well, see, whenever we have solved all these problems regarding heat equation in the previous classes, what we have seen, we have, whenever it was the turn to take the initial conditions, what we have done, we have either we have not taken any condition, else we have taken a condition where only one condition, and we have shown that firstly we have formulated our for mathematical formula using that, I mean, some initial condition is the function of x, and later we have later we have used a constant value for that particular fx, that is equal to u0. Now in this problem, the upcoming problem, we will take some variable initial condition. So the problem is saying that there is a boundary value problem which is being governed by this equation 1 over kappa del u del t, which satisfies the condition u0t ult both are equal to 0, and your ux0 is equal to lx minus x square. We have to solve this. Now again, what we will do, we will take the already solved facts. So we have seen already that the solution for this system turns to be summation n equal to 1 to infinity, some capital En, some constant, e to the power minus n square pi square k by s square t sine n by x over a. So this is the solution with the constant En as 2 over a 0 to a fx sine n pi x by a dx, where n is equal to 1, 2, 3, etc. Now see, very clearly we can obtain the value of En, and we will go for that. So this is equal to 2 over L for this problem. See, whenever, what you have to replace for this two formula, you have to replace a by small l, and as far as I'm observing, no other changes will be required. So this is En for this problem is given as 0 to L, fx is L x 1 minus x, very sorry, this is Lx minus x square, right? Del x minus x square multiplied with a sine n pi x by a dx. Sorry, this is L. So let's do the integration now. So this is saying 2 over L, the first term is Lx minus x square minus cos n pi x over L by n pi by L minus L minus 2x, that is the differentiation of this term, and again integration of this part. So this is minus sine n pi x over L by n pi square, because 2 times integration is being done. Then the extremeless term is differentiation of this, which is equal to minus 2, and triple integration of this. So for triple integration, n pi L cube will be there in the denominator, and cos n pi x over L, and the limits are 0 to L. So what we get, 2 over L, see, minus 2 L cube by n cube pi cube cos n pi plus 2l cube by n cube pi cube. So ultimately we get 4l square n cube pi cube 1 minus 1 to the power n. So En, your En can be now is equal to, either this can be equal to 2, that is whenever your n is some 2m minus 1, so this can be written as 4l square into 2, that is 8l square by now 2m minus 1 whole cube pi cube, and when your n is some odd number, and this is equal to this is equal to 0 for n is equal to some 2m, that is all even numbers when m is equal to 1, 2, 3, etc. So see, this is the constant. So ultimately you can write your equation as uxt 8l square by pi cube m equal to 1 to infinity 2m minus 1 whole cube sine 2m minus 1 pi x by l e to the power minus 2m minus 1 whole square pi square k over l square t. So this is the solution. Okay, we will go to the next problem. Next problem is saying that there is a homogeneous rod, say this is the rod. There is a homogeneous rod of conducting material of length small a. This length is small a and has its ends kept at 0 temperature. So this means if you take your temperature as a set, first say this rod is kept along the x-axis and the first end is at the origin. So this is a. So at 0t this is equal to 0, and at at this is equal to 0 as well. So the problem, again coming back to the problem, a homogeneous rod of conducting material of length a has its ends kept at 0 temperature. The temperature at the center is capital T. At the temperature at the center here, that if we plot the temperature in this direction, then here it is capital T. U a by 2 T is capital T and falls uniformly to 0 at the two ends. So the curve of temperature shows like that. Find the temperature function uxt. Okay, so follow that. First we will take the differential equation as del 2u del x2 is equal to 1 over k del u del t, and u0t uat both are equal to 0, as already we have said for all t greater than or equal to 0. And let now some initial condition to be proposed by this condition. Okay, so how? See, follow that if u if u be the temperature at any point, then u minus 0, that by x minus 0, that is the slope, that should be t minus 0 by a by 2 minus 0. sorry, right, because we are taking the slope and we are making them equal. Okay, so what we get that and another thing, that u minus 0 by x minus a as well, this is t minus 0 a by 2 minus a. So from there you can say that your you can say the initial condition of given. Now follow that, suppose this function we call it fx, and then we have already solved, then the solution should look like uxt is equal to summation n equal to 1 to infinity en sine of n pi x by a e to the power minus n square pi square k by a square t. This is the solution where your en is given as 2 by a 0 to a fx sine n pi x by a dx, where n is equal to 1, 2, 3, etc. So we have to solve this problem, and we have this initial condition given. Now this initial condition fx, as we have seen, this is given as, follow that, this is so I mean we should write it like combining these two, the initial condition looks like, that is that fx, if u at x0 is fx, then this fx is given as follow the first one, so u is equal to, follow that this is 2t x by a, where whenever you are at 0 to a by 2, and this is again is equal to this one, so this is minus t by minus a by 2, so minus, or rather we are turning this opposite, so this will be 2t by a minus x for this range. So now we will solve. So en is equal to 2 by a 0 to a fx dx, etc. So we are taking 0 to a by 2. This is 2tx by a sine n pi x by a dx plus 2 by a by 2 a 2t a minus x by a, that is this value, multiplied with sine n pi x by a dx. Now to solve this, we have, just try this solution by yourself rather, and find that if I am correct or not. This is 8 capital T n square pi square sine n pi by 2, which is equal to 0 if n is equal to 2m, and equal to 8 minus 1 m plus 1 capital T by 2m minus 1 whole square pi square when n is equal to 2m minus 1. So if we impose this, then your solution should look like uxt is equal to 8t by pi square summation m is equal to 1 to infinity minus 1 to the power m plus 1 2m minus 1 whole square sine 2m minus 1 pi x by a e to the power minus 2m minus 1 whole square pi square kappa t by a square. This is the solution. Okay, so what you have to do, you have to just integrate this and find this solution, whether this is obtained or not. Check that. Okay, so to the next point, next problem. Next problem, this is given, I have already written that that this is the equation given and these are the following conditions. So I thought that, well, let's again do one problem from the very first, not using any formula, something like that. So we are assuming that uxt is equal to, we can divide it into, separate it in different sections, where the different sections will be the function of one particular independent variables only. So we are taking x of x and capital T of t, and by this, if we apply this funda in this equation, you can see that this is equal to capital X 0, capital T of t is equal to 0, which is actually giving you that capital X0 is equal to 0. As if you take capital T of t is equal to 0, then your solution will turn to be a trivial one. By similar logic, you can write that this is equal to 0 as well. So what we will do, we will input this in the given partial differential equation. Let's start. So this is d2x dx2 into t is equal to L over k d small t multiplied with x, and we will separately write this equation like 1 over capital X d2x d small x2 is equal to L by k small t dt dt. Okay, so see, this is a function of x and this is a function of t, so we write them to be equal to some constant, and this turns this equation as d2x dx2 minus mu x is equal to 0. Now mu can have three values. We know that if we take the case 1, that mu is equal to 0, then your solution is trivial. Why trivial? Because if you solve that, you have capital X of x is equal to mx plus c, say, and by the conditions given, this will turn to be 0. Second condition, which is saying mu is greater than 0, this also let you a trivial solution. Come to number 3, mu less than 0, and as mu is less than 0, we are assuming that this is equal to, say, some number minus m square, or rather we can write, well, it's better to write n square, so such that we can match our results. So normally we do make our results using n. So this is giving your result as capital X of x is equal to some c3 cos of nx plus c4 sin of nx. Now follow that. If you write x0, which is equal to 0, this is c3, that is c3 is equal to 0 because this part is already 0, and then x at 2 pi is equal to c4 sine 2n pi is equal to 0. Now, as far as it seems, this will turn to be 2n pi, that should be equal to some m pi, and n should be equal to some m by 2. So you can write your result as xm x is equal to c4m sine of m by 2 x. Okay, now if so, then let us write the equation for t as well. Now this is dt minus mu. So minus mu means this should be plus n square kt by l is equal to 0. And solving, we can write, take it that side, take t down, then this is log of t, and that part is simply n square k by small l into small t. So this can be written as capital T is equal to some t, or rather actually this n square, I'm completely converting it by small m, then t of m is equal to c5m multiplied with exponential n square is now is equal to m square by 4 k l t. Okay, and multiplying this two, you can now write u x t, actually un x t. This is the m is equal to 1 to infinity, un x t, this is the sum, and this is equal to, multiplying these two constant, I'm writing c1 m e to the power, there should be a minus, very sorry for that, minus m to m square k by 4l t multiplied with sine mx by 2. So this is your solution. Now, oh sorry, I'm extremely sorry, there should be a m equal to 1 to infinity, there will be a summation sign. Now with this solution we will proceed and we will find the value of C1m. Now as far as we see that u0t is equal, ux0, so this will be m equal to 1 to infinity, write it here like this is sine cube x as our problem was given. So this is C1m. Now this part will be 1 because t is equal to 0, so this is sine mx by 2. Now there should be a Fourier series transform, and we can write it as, or actually we can break it, in which form. Suppose this is equal to, write it 3 by 4 sine x minus 1 by 4 sine 3x. Okay, so there is no cube, but there is nothing like that, so we can now compare. Now see this, if we enlarge this part, what we get, C1 1 sine 1 by 2 into x. Okay, very good. So follow that there should be some particular terms, right? Some particular terms which will match with these terms. Okay, the first term is that, then C1 2, this is sine x, then many other terms will be there, and then ultimately whenever your m will be equal to 6, you will have C1 6 sine 3x is equal to that part. So comparing them, you can write all those C1n, they are is equal to 0 except the fact C1 2 is equal to 3 by 4 and C 1 6 is equal to minus 1 by 4. You can write that, right? And so what your solution then should be? Come to this part. So your uxt, that is, see, only non-zero terms are C12 and C16. So M2 and M6. So we are writing this will be 3 by 4, that is C12, multiplied with e to the power minus, in the place of m we will write 2. So 4 by 4 cancels, k by l t, sine m is 2, right? So this will be sine x, and then this term, and for that your m is equal to 6. So here this will be e to the power minus, this will be 36, so minus 9 k by l t multiplied with sine 3x. This is your solution for this particular problem. Okay, so let's go to the next problem. We will move for some other kind of a problem. I mean, the same differential equation though we will be dealing with. And just give me a moment. The problem is given as that you are given a differential equation k multiplied with del 2u del x2 is equal to del u del t, and you have to solve it for 0 to x2 pi and t greater than small a, and if ux at 0t is equal to ux at pi t is equal to 0 and ux 0 is equal to sine x, you have to solve this system. So let us start. So see, the simple fact is you have to take that solution again, the whole problem, like uxt is equal to capital X of small x and capital T of small t, etc. And then as we know that your solution should look like, see, this should look like this. I am not going to the whole details. uxt is equal to e0 over 2 plus n equal to 1 to infinity en cos n pi x by a e to the power minus cn square t, where your e0 should be given as 2 by a 0 to a fx dx, en is given as 2 by a 0 to a fx cos n pi x by a dx for n equal to 1, 2, 3, etc. and cn cn is equal to n square pi square k over a square. Now the boundary conditions are given, and if you compare them, I mean this solution with these boundary conditions, then what you see that your, I mean you can writing your k is equal to k and a is equal to pi and fx is equal to sine x, which are given. So according to the given data, you have e0 is equal to 2 by pi multiplied with 2 is equal to 4 by pi, and en, this is 2 by pi 0 to pi sin x cos nx dx. This result terminates into 1 over pi 1 minus 1 n plus 1 plus minus 1 n plus 1, rather this is n minus 1 minus 1 n minus 1. Now if your n is an odd number, that is if you write it as a 2m minus 1, then where m is equal to 1, 2, 3, etc., then your en is equal to 0. And whenever your n is even, that is you can write it as 2 into small m, and where m is equal to 1, 2, 3, etc., then you see that your e to m this turns to be 2 over m 1 over 2m plus 1 2m minus 1 is equal to minus 4 by pi 4m square minus 1, where m is equal to 1, 2, 3, etc. So follow that your C2m that reduces to C2m square that reduces to 4m square pi square. So ultimately your solution, you can see this is uxt is equal to 2 by pi minus 4 by pi summation cos of 2mx by 4m square minus 1 e to the power minus 4m square kt. Okay, so this is a solution.